Yeah, hi guys. So welcome to the new lecture. So today we will be solving the new question in joins, that is average time of process per machine. So you can see that we have a very huge description on the table. So I am sure that more, like 50%, more than 50% of the students will actually quit this problem by seeing the description only, right? So it is having so much of big of description, and we are very lazy to read this much to solve a problem, and they have they're categorized it as a easy level problem. Okay, so that's crazy. So let us see this problem, right? Average time of process per machine. So we have been given with activity table, right? So if you go through the schema, we are having four fields: machine ID, process ID, and activity type and timestamp. So okay, so we have enum type and we have a floating point type, timestamp in a floating point. So the table shows that user activities for a factory website. Machine ID, process ID, activity type is the primary key. Okay, so we do not have any, primary key contains not only one field, but it is having a combination of three fields. Okay, machine ID, process ID, and activity type. Right? Machine ID is the ID of the machine. Process ID is the ID of the process running on the machine ID. Okay, machine ID. Activity type is the enum category that will contain start and end. Cool. Timestamp is a float representing the current time in seconds. Okay. Start means the machine starts the process at the given timestamp, and end means the machine ends the process at the given timestamp. Cool. The start timestamp will always be less than or equal to end timestamp for every machine ID and process ID pair. Cool. It is guaranteed that each machine ID process ID pair has a start and end timestamp. Okay, so huge description. Now they're asking us, there is a factory website that has several machines running the same number of processes. So please be careful when reading this, these kind of questions. They have already, it is very benefiting, right? This bold text, it is very benefit, because if you go back some 10 years back, it was completely, it would be in a single plain text, and there was no bold or something. Right? So we will be underlining in our minds, right? So write a solution to find the average time each machine takes to complete a process. Okay, the time to complete a process is the end timestamp minus the start timestamp. The average time is calculated by the total time to complete every process on the machine divided by the number of processes that were run. Cool. The resulting table should have machine ID along with the average time as processing time, which should be rounded to 3 decimal places. Okay, table can be in any order, and yeah. So if we go through this test case, right? Let us go through the text case, what it is saying. So we have this table with 4 columns, right? So if you go through the first row, machine ID, so 0 machine ID, and you have totally 0, 1, and 2. So you have totally 3 machines, that is 0, 1, and 2, and you have process ID 0, start, and this is particular timestamp, and 0 machine ID, 0 process ID, and timestamp, right? So if you go scan this table, you can see that we have totally 3 machines, and every machine is executing 2 processes. Okay, so that is process ID with 0 and process ID with 1. Okay, so they are saying that process, on machine ID, on 0 machine ID, process ID is starting at 0712, and it is ending at 1.520. Okay, and it is again starting one more process, that is process ID with 1 at some later timestamp, and it is again ending, right? So similarly for 1 and 2 also, they are also executing the processes with ID 0 and 1, and at some particular timestamps. What they've asked us to find out is, they've asked us to find out the average runtime average runtime of the processes in every machine, for every machine, right? Average time of process per machine. So how do you calculate this? Okay, so to calculate the average, I hope everybody is well versed in basics, right? So average means what? We'll be having, if you have some list of numbers, average is calculated by summing up all those numbers and then dividing it by the, the length of that list, or number of elements in that list, right? So basically, here we do not have the runtime, right? If we need to calculate the average runtime, and we do not have any runtime, but they have also given that the runtime, how to calculate the runtime. So to, the runtime of the process is how it is calculated. Simple, right? So we have the end time and we have the start time, right? So if we make this difference, right, end time minus start time will give you the runtime of that process. So if the task number one in this problem is to find the runtime, okay, find the runtime of every processes, find the runtime of every process, that is machine id 0 and the process id is, for process id 0 we need to first find out the runtime, how much time it was took, and we can do that by end time minus the start time. So for every process on every machine, we need to first calculate the runtime. That is our first task. Okay. Okay, so if I, the first step in this problem is to find, okay, or calculate the runtime for every process, in machines. Okay, and then once we get the runtime, right, okay, and once we get the runtime, right, so we can just use the, we can just find out the average, right? So how will we finding out the average? So suppose this, right, for this thing, for whole this thing, uh, we'll be having one runtime for these two things. Okay, so if you take up, so we'll be, firstly, how we'll be calculating the runtime? So firstly, this is the process machine ID and this is the process ID 0. So if I take the end time minus start time for the process ID 0 in machine ID 0, so it would be some value, right? So 1.520 minus 0.712, it would give me some value, right? So it will give me some value. For assumption, I would just take it as 0.8. Okay, and then there is, this is the runtime, this is the runtime for process id 0, okay, in machine id 0. Okay, and similarly, if I take runtime for process id 1 in machine id 0, it would be 4.120 minus 3.140. I would just assume that it is taking some 0.9. Okay, so these two have been given the runtime as 0.8, and these two have got it as like this. Okay, so this is the total runtime for process id 0 in machine id 0, and this is the total runtime for the process id 1 in machine id 0. So how will I calculate the average for machine id 0? Simple, right? So I have this, so what I will do, I will do 0 this, I will sum up these two things, 0.8 plus 0.9, and then I will add by total number of machines. So I have sorry, total number of processes, right? Total number of processes are how many? There were two processes, right? So divided by 2. Okay, so this will result me in the average runtime. Okay, average runtime of the processes. Okay, yeah. So if you go through the explanation also, they have given you machine ID's average time is 1.520. Okay, that is end time, right? For process 0, end time is 1.520. So this is for the runtime of the process 0, and this is the runtime for the process 1. And if you sum up both these two things and if you divide it by 2, because there are total two processes that were running, you get the average runtime for that machine. Okay, so first thing is we need to calculate the runtime, right, to every runtime for every process, and then we can take out the average. Okay, take out the, or calculate the average, calculate the average runtime of the processes per machine. Okay, so this is the thing, as these two are the steps. Okay, So guys, now how we will be how we will be able to calculate the runtime, right? So guys, if you have watched my previous video, that is on the rising temperatures, so there you have seen that how we have made one table, how we have joined it by itself, and how we made that table into, like, left table is having a specific date, and its corresponding right table was having its, corresponding right table row was having its previous day's record. Okay, so then it was easy for us to compare the temperatures, right? So similarly, the similar logic is being used here. Okay, so here also, if we can, if we can somehow use the joining, okay, if we can somehow use the same table and join in such a way that, if I could have my, if I in the same, if I could have, for this particular row, the right table corresponding row would have this end value, then we could, do, different, right? Then we could easily find the difference between the timestamps, right? So here it is, like, here we have all the tables in one, like all the rows in one row. If if we can somehow join this table in such a way that my left table would contain all start values and my right table would contain all end values, then it was very easy, right? So this is left table and this is right table, and if I do right table dot timestamp minus left table by my dot timestamp, I would get the runtime, right? So same logic, guys. It is absolutely connected with the previous problem. So if you have not watched, I recommend you to, first please watch that video, and then it will be very easy for you. Otherwise, if you are a, peak learner or good learner, fast learner, you can just watch this video also, no problem. So what we need to do is, we need to do the join, okay, self join in such a way that all my start, okay, all my start activity type rows will be in my left table, and all my end records, the records with the end activity type will be on my right table. Okay, so if we could do that, the first step is that. Okay, so how we will be doing that? Okay, we'll be using the self join samely, like how we have done in previous problem. So we'll start with from. Okay, so from activity A, right, join the same table activity B alias, right, alias B. Now comes the join condition. So how we will be joining it? Okay, what like what we have thought all my left table should be coming on, sorry, all my start, okay, activity type start should be coming on the left table, and all my end activity type rows should be coming on the right table. Okay, so first let us see that if I match with, if I match with machine ID and process ID, right? Firstly, I need to be make sure, I need to be sure that only the same machines, the same machines should be getting matched, right? So okay, so let us see, let us match it first. Okay, so let us match it. We know that the primary key is these three things, right? But we cannot match we cannot include the activity type, because start and start will not make any sense, right? So first let us see, if I join with the same machine ID and process ID. Let us see. So a dot machine ID equals to b dot machine ID, right, and a dot process ID equals to b dot process ID. So let us see, guys, what this will result. Okay, what this will give us. Select star. So we'll see, guys, what it will give. So if you see this is a very big output, and if you go through the rows, first row is having machine ID 0, process ID 0, activity type end, and timestamp 1.52, and it has matched with the same machine ID and process ID, and it has matched with the start. So these two record, if you see this is okay, right? So we have thought the we have thought the either way, like we have said the start should be on the left and end should be on the right, but it is also okay, this record is fine. But if you see this, this we do not want, these type of records we do not want. Okay, so if you if you include only these two conditions, what it will happen is, you can use the cross join example, guys, to join. You can use the cross join example. like how I said in the earlier videos, right? You can just use that similar intuition and try to understand this join. Okay, so if what happened is this, if you consider like this row, this particular record, so what I'm doing, a dot machine id equals p dot process id means it got matched with itself. Okay, it got matched with itself also, which is very useless, right? We do not want these two records. We want only end and start. Okay, we do not want start and start to be matched. Okay, so you can see here 0 0 start and start. We don't want anything like this. We want either end should be coming on the activity type, right? End and start should be there. Okay, I don't want start and start, but I want end and end. So if I could put one more condition, and a dot activity type should not be equals to p dot activity type. All right, so if I execute like this, so now I will not get start and start. Okay, start and start will be not be getting matched. Okay, so now you can see that for 0 and 0, end 1.52, right, and start, and again I got start and end. So you can see that I've got two records. These two are the ones that we were satisfied with, but we are having kind of two times we have got it, which is not relevant, right? So we can choose only one from this record. So both are correct, only one, we can choose any one of this thing. Okay, so what we have said initially when we are designing problem, we want all the start to be on the left side. So what we will do is we will change our condition. We'll change our condition slightly, right? We'll change our condition slightly. What we want is, we want all the left table rows should contain the activity type of start. So my left table is a, so I'll say a dot activity type will contain the start, guys. Okay, and right, and my b dot activity type will contain the end type. Okay, so if you add these two conditions, right, then I'll be getting only this particular row. Okay, so now we will execute this. And now you can see, my dear friends, for every process in every machine id. Okay, so initially I was having 4 rows. Okay, that was having end time, start time in different rows. Now what we have joined is, we have joined the two tables by itself, right? We have used self join in such a way that now for every machine, for every process in a machine, it will contain only one row. So process id is having now only one row. So it has start has been matched with the end. Okay, so here's the process id 0 that has a start. So this is coming, all these 4 rows are coming from left table, and all these rows are coming from my right table. Right table row is having the end type. Okay, so this is the same process, it is having the end type row on the right table. Now it becomes very easy for us to calculate the runtime, right? So what we can do, how to find out the runtime? We can just find out the runtime by taking the difference between the both these timestamps. Okay, that is my right table dot timestamp minus my left table, that is b dot timestamp minus a dot timestamp, will give me the total runtime for this process, that is process id 0 in the machine id 0. Okay, so we can what I will do is, I'll just select few columns instead of selecting stars. Okay, so I'll for betterment of understanding, I'll just keep it. Okay, I'll just keep this uh, intermediate result, I'll comment it out. Okay, so what I will do is, I'll just select few things. Okay, so you can see that all these columns are, when we are doing self join, it is absolutely like all columns are ambiguous. So we need to specify absolutely the aliases. Okay, so I'll select from, you can select from either, because all are similar, right? There is no difference. Okay, so a dot machine id, I'll select the machine id, I'll select the process id, and for every process id, now how we will be calculating the runtime. So I've said you, right? So my right dot timestamp, that is b dot timestamp, that is end time, right? So it is containing the end time, b dot timestamp minus a dot time stamp. So this is actually the runtime of the process, guys. Okay, so this is actually the runtime of process. And now One sec. Oh my god. So this is actually the runtime of my process. You will get to see the runtime of each and every process. So you can see, my dear friends. So in the machine ID 0, process ID with 0, it has took 0.808. Okay, and in machine ID again the same machine, process number 1 has took 0.9. So similarly goes for 1 and 2. Now once we get the runtime, it is very easy to calculate the average, right? So if you can, if you can use the I mean normal formula, you can, you can actually take the sum of these two things and then use the count. Okay, count of rows group by 0, you can use that. But actually we have a very good function called average in aggregations, like provided in aggregations. So you can simply, what we can do is we can use the average function and then grouping it by the machine ID, right? So if you use the, if you group it by 0, if you group it by 0 and then use the average, so automatically it will perform all that, sum of these two things and count of how many rows. So it will perform all that things, no need to use extra functions. So what we will do, we will firstly group it by the machine ID. Okay, so group by dot machine ID. And guys, see, we are not taking the process ID. Okay, so if you group it by both machine ID and process ID, it is no meaning, right? So it will give you, it will result you in the same number. Okay, because we need to calculate the average. Average will only work when you have many many rows in the same group. So you should not be including the process ID. So process ID I have just included because to show you like how the runtime of every process has been calculated. So I'm commenting it out, right? Now I'm grouping it by the machine ID. Now this is the runtime, guys. So this is the runtime. Okay, now we will be, this is the whole runtime, and on that runtime we need to pass the, we need to give pass it to the average. Okay, so now this average function will take care of everything, right? And it will give you the average runtime of that machine. Okay, so this is the average runtime. Okay, average runtime of processes. Okay, average runtime of process, okay, in machine. Okay, that is machine is here. So now if you run this, guys, so you can see that, yeah, so you can see that process I, for every process I got the average runtime. Okay, for every process we have got the average runtime. Okay, so the thing is, I think the name should be the processing time. Okay, so processing time, and if I run this, yeah, so our test case passed. Okay, so before submitting, guys, let us see if we have missed anything. Okay, so same number of process, the time complete, we have completed this. Average time, yeah, we have calculated the average time also, right? We have calculated the runtime first and then we have calculated the average time, and the resulting average runtime processing time, which should be rounded to 3 decimal places. So we should here add one more thing, that is rounding. Okay, so if we pass this total average, and it should be rounded to 3 decimal places. Okay, so this average function was taking care of our runtime, like how we have seen runtime. So it will take care of that, take care of that, calculating the average. Okay, now once after the average is calculated, we need to pass it through this round function. So round function, like it should have 3 decimal places. The second parameter is the specifies the number of decimal places. So this is the thing. So let me just okay, yeah, calculate the average time. I have completed it over the above only, right? So this is the solution, I think, guys. So let me just run on the backend test cases and check if it works fine. Yeah, yep. So it has passed on all test cases. So yeah, that's it from this solution problem, and we can also go and check other solution. So yeah, pretty much the same. Okay, so they have also used the same logic. Okay, so it is always best to check other solutions, guys. It is a very good habit because we could learn many things by reviewing others code. Okay, so yeah, that's it from this problem, guys. I will meet you in the next question. Thank you.